Good day, everyone. In our previous lecture, we were able to convert the requirement into a conceptual idea about what the drone required should be. Now let's refine it further and further to discuss about which type of drone will be suitable for the application. In our today's lecture, we will be deciding on the type of drone. This is our next step in designing the drone, which is basically be useful for our application. Let's look at it in further detail in our next slide. To begin with, let's look at the factors deciding the type of drone. Some of the factors that decide on the type of drone are: first, deciding how much time the drone is going to stay in air for doing the mission and coming back. If the drone requirement in flight is long, the drone has to carry a bigger battery pack, which means it will be a huge multi-rotor or even further a fixed wing. Second, the kind of space that the drone will be carrying out the mission. For example, if you're looking at flying the drone within a constricted space, then the only option available is a small multi-rotor drone, since fixed-wing drones cannot fly in constricted spaces. Third, the kind of availability of infrastructure near the location for carrying out the mission using the drone. For example, a fixed wing requires a takeoff away near the location to carry out the mission. So even though a fixed wing is more suitable for a mission, based on the location, we either will have to use a VTOL or use a bigger multi-rotor for carrying out the mission. Finally, the cost or budget that is currently available for the drone. As we talked in our previous lectures, fixed wings and VTOLs are much costlier than multi-rotors. So, depending what budget you have for the drone, you can decide on the type of drone you can use for the mission. Let's further revise the differences between the fixed wing, multi-rotors and VTOL in our next slide. As we must have discussed in our previous lectures regarding the different types of drones, let's revise one more time the difference between the same. It is important to keep in mind these types of drones, especially while selecting which type of drone you want to use for your mission. Fixed wing drones, such as the Q200 and Datahawk, consists of a rigid wing that has a predetermined airfoil, which makes flight capable by generating lift caused by the drone's forward airspeed. This airspeed is generated by forward thrust, usually by the means of a propeller being turned by an internal combustion engine or an electric motor. The main advantage of a fixed wing drone is that it consists of a much simpler structure in comparison to a rotary wing. The simpler structure provides a less complicated maintenance and repair process, thus allowing the user more operational time at a lower cost. More importantly, the simple structure ensures more efficient aerodynamics that provide the advantage of longer flight durations at higher speeds, thus enabling larger survey areas per given flight. Another advantage of fixed wing drones is that the flight characteristics due to the natural gliding capabilities with no power. The only disadvantage to fixed wing solution is the need for a runway or launcher for takeoff and landing. However, VTOLs and STOLs solutions are very popular to help eradicate this issue. Also, fixed wing aircraft require air moving over the wings to generate lift. They must stay in a constant forward motion, which means that they can't stay stationary the same way a rotary wing drone can. This means fixed wing solutions are not best suited for stationary applications work like inspections. Rotary wing drones consist of two or three rotor blades that revolve around a fixed mast. This is known as the rotor. Rotary wing UAVs also come in a wide range of setups, consisting of a minimum of one rotor, which is a helicopter, to three rotors, four rotors, six rotors, as well as eight rotors. Like fixed wing solutions, these setups can be further broken down. For example, a Y6 setup consists of a trirocopter with twin rotors on each arm, one pointing upwards and one pointing downwards, and an X8 consists of a quad rotor with twin motors on each arm. Again, each setup has a own unique characteristics, advantages, and its disadvantages. The biggest advantage of rotary wing UAVs is the ability for takeoff and land vertically. This allows the user to operate within a smaller vicinity with no substantial landing takeoff area required. Their capacity to hover and perform agile maneuvering makes rotary wing drones well suited to applications like inspections, where precision maneuvering and the ability to maintain a visual on a single target for an extended period of time is required. On the flip side, rotary wing aircrafts involve greater mechanical and electronic complexity, which translates generally to more complicated maintenance and repair processes, thus meaning the user's operational time can be decreased, which can occur increases in operational cost. Finally, due to the lower speeds and shorter flight ranges, the operator will require many additional flights to survey any significant areas, another increase in time and operational cost. So this gives an idea between the difference between the fixed wings, multi-rotors, and hybrid drones. The selection of the drone is based on two things: the factors deciding the type of drone and the advantages and disadvantages using different type of. In my experience, a multi-rotor usually does the work. The reason being it comes within the budget we are able to procure the parts required and build and test it safely as per the requirement. Usually bigger batteries or using hexacopters or octocopters can do the mission required. However, there have been instances where we had to survey acres of mines, which proved to be difficult with a multi-router because of the multiple times the pilot has to move and the dependability on the batteries in terms of charging and discharging time. In that instances, we had to go with a multi-rotor design. We had to go with a fixed wing design. My apologies. In our present course, we will be mainly focusing on the multi-rotor design aspects in terms of selection of motors, propellers, flight controllers, and so on. So for now, let us assume that we have finalized the multi-rotor for our current course. The details of which multi-rotor to select and why it will be selected will be covered in our next lecture. To summarize, we looked at what factors decide on which type of drone to select, what are the advantages and disadvantages of selecting a particular type of drone, and why. As we discussed, we will be selecting a multi-rotor type of drone for our present course. In our next lecture, we will select what kind of multi-rotor is suitable for our application. Thank you very much.